He is now working as a chair electrical engineering division of IISc Bangalore. He has earned his BE from Bangalore University, followed by his ME and then also PhD from high voltage engineering from IISc Bangalore. And he has many awards to his credit. He is now editor of several reputed journals. Also, the expert member of multiple international committees on lighting and lighting studies. He has many publications in some reputed journals. Now he will be giving a lecture on general aspect of lighting protection and also issues with the new devices. I welcome Dr. Uday.
Thank you very much, sir. We go there or here? Here. Thank you very much. It's a privilege to be here because in my student days, everybody is talking. Atmospheric science people, they solve 10th order partial differential equation, 12th order partial differential equation, and they use maximum computational power in the campus. So that's the reason I'm very privileged to be here. And I remember one statement by my professor. He said, Lord Simpson did balloon experiments in Pune to trace to quantify the charge distribution in the cloud. I'm sorry, my knowledge on this is not that great. Then I thought that may be the reason why you have a topical metrology institute in this place, the country. So here, this talk I will try to be very basic and focus more on protection, because you know the science behind charge separation much better than anyone else in the globe. But to make it complete, some additional aspects which may be very fundamental are also included in the presentation. And as my colleagues say, your presentations are very dry. So I downloaded some videos from the web to make it more attractive. And maybe we'll start. If the things are elementary, kindly forgive me, because I really don't know the audience. So some of them could be very elementary. But the goal is to stress upon the lightning protection, the devices, what is there in the market, which science community has never endorsed, and we're still in the market, whatever we do. For us now, for today's discussion, the cumulonimbus code is the only source of lighting, because we are including in today's discussion lighting produced by desert storm, underwater nuclear explosion, and volcanic eruption. Those are not included. And this statistics, I'm very careful on this statistics, because this is generic data, what is given to me by the literature. Whether it's applicable to Indian subcontinent, you people are better people to judge and say. So anyway, for us, today's discussion, we will mostly concentrate on the protection of structures on the ground. Even though at the end I'll show some slides on protection of aircraft. For us now, because we need to have a definition before we start our discussion. For us, for today's discussion, lightning is a luminous, very long, high current discharge in the atmosphere. Why I'm mentioning again and again is the people who go for trekking, they see some discharges in the cumulocongestus. That is not part of our discussion because the current involved are pretty small. The damage is sort of minimal there. So we are talking about high current, long discharges in the atmosphere, mostly between cloud and the ground. And for all electrical, electronics, and others, it's an electromagnetic event. That's the reason whether it can affect things far beyond its reach. These are not mine. Kindly note, download from the web, but the link, the reference is missing here. So I'm sorry about that mistake because I'm not supposed to do that. But nice to have these time-resolved pictures so that we can have a basis for our discussion. Most of the time, we are talking about cloud-to-ground lightning, more specifically downward cloud-to-ground lightning. So where some very fine discharge starts from the cloud, maybe in the bottom small positive charge pocket and the negative charge center, which is around 3 to 5 kilometers in average, supposed to be at that level. And this discharge is so faint, currents involved are typically less than a kiloamperes, sometimes hundreds of amperes. It propagates in steps towards ground and then comes close to the ground. There will be upward discharge from the grounded object. And that bridging happens, completing the so-called short circuiting. Charges flow from ground to the cloud. They may be negative or positive depending on the phenomena. And what we really see as lighting is the the second phase called return stroke phase. This phase we cannot see because of time resolution, because of the faint nature of the discharge. What we see is only this. Sometimes you see flickering. It's basically that you will have multiple events separated by a fraction of a second, and sometimes you are able to see the individual events as not very clearly, but as a flickering the phenomena. So this intense current flow phase is the phase what we worry from the protection aspects, because all the thermal, mechanical, electrical damages are due to this phase of the lightning. So damages are many. I just wanted to comment on two, even though these borrowed pictures. Fortunately, in tropical country, our tree is not so dry. Oil contents are not that high, so we don't see catching of fire so often. But one point I want to say, I'm from coastal Karnataka. So people ask me what to protect my coconut tree. Some of these trees have xylem and phloem in the center. So because of the current flow, intense pressure will kill all the cells. Coconut tree will die, unfortunately. On the other hand, there are some trees where the conducting fluids are flowing in the periphery. They will have surface damage, the tree will survive. So there are both the cases possible. And other question mostly asked by people is, can we use RCC structure, steel in the RCC as the down conductor for conveying lighting? Normally for houses, we don't prescribe that because the overall cross section is small and the voltage and field levels are very high that can puncture the concrete. Concrete is a porous structure. The microwires will have air discharges during the event. That pressure developed by the discharge can rupture the concrete. For a very huge structure, we can still use the foundation or the RCC steel as the down conductor. And this one, very sad-looking picture, has inserted intentionally for two reasons. One is lighting could have been elsewhere. The induction to the fans would have caused a serious shock because human body is so susceptible. It needs few milliamperes to pass through the heart region to have a cardiac arrest. So you don't need milliamperes of current. So induction is somewhere, activity somewhere else. This fence can act as an antenna to pick up the voltage that can still cause a fatal damage. Or it be possible that the selected current path to the ground, and fence being grounded at both ends can actually have a current concentration, and that can also cause fevers, such fatal shocks. Of course, the petrochemical industry, windmills, which are now part of our move towards renewables, one of the structures which is frequently struck by lightning. But I want to just comment on this. I don't know how many of you know about Ambassador car. My childhood, I seen the car in childhood. I still like it because it has good structure. Anybody, you can pack in at least 20 people inside without any problem. Those are metallic body cars. They are more safe for us. Whereas we have now car bodies are mostly fiber based that can cause severe damage. If the tire is wet, the discharge path will be on the surface of the tire. If the tire is not wet, dry, there will be a puncture. Just an example, I'm quoting this. And this is a video taken by a passenger in Japanese airport. The aircrafts are frequently struck by lightning. In 1920s and 30s, many aircrafts were lost in the process for various reasons. The latest one is in 2019. The Russian aircraft during landing caught into fire not because current is very high there. Current is tolerable for metallic body aircrafts, not for fiber body aircrafts. However, near the engine, we have fuel air mixture that is highly ignitable. If there is sparking there, can cause explosion. That is a common reason for catastrophic failures. And these are the pictures not to scare you, because nothing is safe in this world. Traveling in the road is also not safe, but damages can be very high because when you use fiberglass based or carbon steel based composites, there are mechanisms to overcome. The radar portion is frequently damaged because that is insulating to make the radar signals to transfer in and out. But that is a common place of damage, not so serious, but other things can be catastrophic. And lightning will not spare anybody on the Earth, including the satellite launch pads, rockets. Even Apollo mission was stuck. So at that time, I think the amount of solid state devices were not that high. Vacuum devices can have a better EM compatibility. So things were in order. And now comes a question. These are known for centuries. And that time, who actually started this basic what you call research and protection? This is power engineers who want to run transmission lines. These lines run for example, in our country, the 220 kV and above lines span more than 5 lakh kilometers. They span from one end to other end, go through different geographic areas. Somewhere maybe desert storm. Somewhere the crowds with the charge separation. So they are frequently stuck. So Japanese colleagues have actually picturized, took a video camera, automatically setting in to capture what happens. These are the things known earlier, but now quantitative data is available with the measurement and system. So this is a schematic now. So forgive me if there are mistakes in this, because this is from a book taken, which is written, I think, 40 years back. Typically, we believe, you can correct me, that the negative charge, at least in the tropical region, negative charges are in the bottom, carried by the water droplets, and positive are in the top region of the cloud. This height is around 3 to 5 kilometers. This is around 10 kilometers. This picture is useful for subsequent discussion. There are regions where the inversion happens, mountains region in Japan, but I'm not a person who has any knowledge on this, so I will not speak on this. This is a model where I will start our discussion. So it's a charge distribution, because somebody I know, young, I think 4th standard boy was asking me, if there are charges here, why should it hit the ground? It should be a discharge here. As you know, most of the discharges are inside the cloud, not outside. Intra-cloud discharges are very high in number, most probably 75%. And that people mistake with inter-cloud discharge. Between cloud discharge, I have never seen, even though it's categorized. But within the clouds, yes, between the clouds, I doubtful. Cloud to ground, obviously, because we have, even though separation is 2.5 kilometers, this Earth acts as a imaging plane. So as a result, there will be a equivalent opposite charge image in the ground. So field is still high here. That can cause a problem. But now, from the protection perspective, we need this classification. The cloud structure is very schematic here. So we have negative cloud to ground lightning, in which we have discharge starting from the cloud, coming towards ground in the stepped fashion, like the first video what I have shown, or mountain. On the mountain, we have a tall tree or a tower, transmission or microwave tower, which can actually start the discharge heading towards ground. So heading towards cloud. That can also complete the path. And typically, this will involve lower peak current, but longer duration as compared to this. Because it's not only current, it is the rate at which you pump in charge is important from protection perspective. In other words, peak current is important, not just the integral of current. So there are many differences here. But this is not included in the normal standards for lightning protection. So normal standards talk only about negative cloud to ground lightning. What about positive? I think you people have to tell me, because one of the publications I saw, more number of positive lightning is possible in certain seasons in country. Earlier, the textbook says only 10% of the cloud to ground lightning could be positive. And I will have to go with their data because it's required for our satellite launch pad lightning protection. And I think one of the references shows it can go up to 30% in some seasons. Very nice. I want the geographical distribution so that we can use it for design. Then now the positive cloud to ground lightning, we vary from the protection perspective for simple reason. This will have larger current magnitude and larger duration. That means the damage from thermal and mechanical perspective could be more for positive lightning. Even in transmission line, we use adjuster for protection. Energy dissipated is much higher there. So positive lightning, even though it's slowly rising current compared to negative, we vary because of energy and peak current amplitude. Whereas for radiation, induction, negative cloud to ground lightning is a concern because of very fast rising portion. So with this, I think next slide. So this is one interesting one. Sometimes you have to visit some place, college, engineering colleges and all. When they say 10% of the strokes will be positive, one young boy raised his hand. What will happen to positive charge? You said only 10% comes here. Then I said current duration is large. But okay, but what happens? This picture is very nice and interesting. There are discharges observed above the cloud towards the ionosphere, called spides, blue jets, and so forth. They are believed to have this balancing mechanism, positive, eminent polycyclic charge are believed to go to atmosphere. This question I don't have an answer. Earth is around minus 250 to minus 300 kilovolts with respect to ionosphere. Why? I don't know. And in the fair weather, the air is not fully insulating. If you take the large area, it conducts around 1.8 kilometers per second towards the ionosphere. That means I should discharge very quickly. But lightning is believed to replenish the lost charge Typically, on the average, 50 to 100 lightning flashes happen per every second. But average it over a year, not that every second it happens. So it is believed to replenish the charge lost by the Earth. Why this is there, I don't know. I'm not, but very interesting one. So all of us are floating at minus 250 kV. You can be very proud of that. So regarding because we are talking about protection required because we need to know that what the casualties or damages. Mostly thermal, mechanical, electromagnetic, and threat to life. In thermal, of course, it looks very sound, but not really. The temperature of the channel rises within 3-4 microseconds to the atmosphere temperature to even 30,000 degree Kelvin. It's such a fast rise of temperature causes a shock wave. If you are very close by, the last thing what you hear is the thunder. It will rupture your drum. If you are slightly far away, no issues. You will have a painful hearing. Afterwards, you will see the murmuring. So if you are very close, you will not see the murmuring, only one sound. If you are slightly away, you will hear the murmuring because all the other discharges will produce equivalent sound. But however, because the density of air is so small there, by itself it cannot cause ignition of fire unless you have a very, very volatile material. It is actually the current, overall current and continuing current responsible for the burning or the fire accidents. But nevertheless, this is sufficient to cause melting, bonding, ignition of the joints and other things. This is the first source of damage. Then, of course, it produces nitrous oxide, tons of nitrous oxide required for the trees and so on and so forth. Mechanical, this is important for us because especially airborne vehicles and other places, the mechanical force can rupture the conductor near the bend. It can actually cause rupturing of the joints, or you can weld the joints. These are the problems faced by airspace as well as some of the other the automobiles. That is a concern to us. Electromagnetic is generic, whether it is local or global. It can be here, the effect can be felt tens of kilometers away, or you're part of the system. You see the severe electromagnetic event, which manifests itself as voltage or current. Because finally, we talk about voltage and current. Behind that, they have some electromagnetic induction, then also have electrostatic induction, so on and so forth. Threat to life, yeah, this is a matter of concern. There are a lot of slides here, but I eliminate all of them because if somebody poses a question on the terminology itself, I don't know. I'm not a medical person to talk about, but there are some things I want to highlight. One of the things is the discharge. Person survives. Actually, no, not really lucky. We'll have these are just figures typical of high voltage discharge. But more than that, there are many things happening at the moment and afterwards. In summary, instead of going to each and every part of this, person survives, he'll become burdens to society because neurological disorder will start, sleep disorder will start, his character will change over time. He becomes kind of a helpless person. So as a brutal man, I'm telling you, if they say unfortunate event, better to die than survive because you become burden to society. You will not be able to do regular activities. You cannot even read things after time. So people who claim that I have a lightning stroke and all, 99%, there was a strike somewhere, a parallel path, a small discharge would have struck them. I have met some people who say they're struck by lightning. No, because the atmospheric pressure there is more than 40 that can break the skull. The skull is all right, means he is not struck by lightning. A small side branch would have struck. Basically, we want to say that lightning strike should not happen to anybody. If it has, it has become a problem to the society later on. So this is not mine. This is taken from NOAA.gov because they said you distribute it freely. What are the rare possibilities? One is very rare possibility you are walking in a terrain and strikes you. Kindly note the lightning starting from a few kilometers above your head. It will not know that you are walking there. Till the last moment, no discrimination is possible. It cannot see any tree. It cannot see any building. The last step only it can see. Therefore, just because you are there, there's nothing from heavens coming to you. It's only that incidental that you are there. That's all. Because this is a misconception is there. This is a wrong picture. This current is flowing through the tree can give rise to a side flash. Picture is wrong. That's also fatal because as I told you, current required to cause the cardiac arrest is only few milliamperes passing through the heart. You don't need kiloamperes there. Or you may be walking in the ground, current is flowing to the ground, causing a step potential. And because you're walking there, you get a serious shock due to potential difference between your legs. So, or that's the same thing shown once again here. Or it may be possible that strike somewhere else, but the induction to the fence is responsible for a shock, or fence may be carrying part of the current. And a rare event, actually strike is elsewhere, but you are there, a discharge is starting from your head. That can also cause a severe shock to you. So there's no discharge to you. You are nearby, there was a discharge starting from your head, but that's sufficient to cause the so-called fatal shock. Anyway, now we will go to more of the numbers, quantification, because without quantification, we cannot talk about protection. So this is a time resolved picture of the cloud to ground lightning. The dotted line is indicative of initial faint discharge, what you have seen in the first video. So these are time separated. It goes in steps, comes close. This is time axis. This is height from ground. This is cloud-based kind of thing. These faint discharges lower the charge from the cloud to the ground. You may ask a question. Cloud is not a conductor. Yes, you're right. So there's a discharge towards ground. There's a discharge inside the cloud also simultaneously. But people sitting in the ground cannot see what is happening in the heavens. So they will concentrate mostly on the what's happening here. But this happens simultaneously. Then we have the charge lowering will cause field intensification in the ground. That will cause a upward flash discharge and returns to current or charge flows from ground to the cloud. There could be some gap. There could be some continuing current, some gap. One more such event will happen. Typically 3 to 4 such events will happen. And to give numbers now, people ask what's the voltage involved. Cloud is not a conductor to define a voltage. If you go point to point, voltage will change. Typically, the estimated potential is 50 to 300 million volts. So, for example, if the transmission lines are typically 220 kV, 400 kV, 800 kV, 765 kV, and 1200 kV line is under plan in India. China is operating at 1100 kV AC line. These are the levels you have. And you have impulse voltage generators in the laboratory, which can go up to 20 million volts, which are kept outside the building. You cannot keep inside the building. But look at this, 50 to 300 million volts. Can we store? No, if you want to store this amount of charge on a conductor, on a conducting surface, we need a balloon of 300 meters floating in air that you cannot control. It's not possible. Then the number of events could be very large. Temperature has spoken. Power density, this is a magical number. Power density is so high, maybe higher than what is there in nuclear reactor. However, energy is nothing. If you convert it to 1 unit in home, 1 unit in home is, you can see, for example, 1 kilowatt into 3600. That is 3.6 mega joules. What we consume is so large energy. This energy is nothing. Even if you collect all the energy, hypothetically, comically, if you can collect all the energy of the lightning in the globe, you may supply power to a small village, only for lighting, not lighting. So there's no energy whatsoever. People talk about this energy, no energy. Energy, because energy is dissipated in a very short interval of time, that causes all the problem. And close by, sorry, if the last thing what you hear is thunder, if you are able to see around your server, so you're not close to the channel. Currents, all impulse currents, lasting for few of the maybe less than 100 microseconds, goes in the range of 31 kiloamperes per negative, positive 60 kiloamperes. Rate of rise is so large. The charge per stroke is not that high, 7.5 coulombs or 80 coulombs. But don't worry about charge, because 1 coulomb is so huge a charge. In practical transmission line, even runs up to 300, 400 kilometers, will not have 1 coulomb separated. No, that is a huge charge for that matter. So now, this is a gist of what is already there. And some of them which are not into standards of these items. Earlier people thought each of this channel will have only 1 termination. Then the video recordings of the event showed, no, it can have 2, at least 30% can have 2 earth termination. Because these separate later would have propagated independently. One makes connection and the other also makes connection with a small interval of time, maybe less than a few milliseconds. Now it is found that some places have more number of multiple ground connection. This has ramification on the protection and other things. And there is another stage when it's bipolar lightning. In the beginning of the current, one polarity charge is transferred. After some event, other polarity will come into action. Very funny thing. How can it be possible? Basically, the cloud dynamics, maybe initial negative charge is put onto the ground. Then when the clearance is done, there's an internal discharge within the cloud, which actually connects the positive charge center to the channel. If there's some time gap, and the lightning becomes bipolar. This is not rare, but not very common. Unconnected upward leaders, all tall buildings and trees will send upward discharges during event, but they are not successful. They will not be able to do anything, but they are in common because they have their own ramification. Now I'll spend some time onto this. This is an important picture for me. This is taken from IEC standard. What should I do to protect my building? So here protection is a terminology used by in different contexts. First and foremost thing is I don't want current to flow through my structure. Means I need a dedicated path for the current to ground. That is the first job. How to do that? Looks very simple. Yes, Benjamin Franklin thought about this not in a correct way, in a wrong way, but very 200 years back or more. You put a air terminal, either a wire horizontally put or vertical dots, so that the so-called lightning will see it first in the course, because seeing is not possible. First, then provide a so-called low impedance path to ground, and try to dissipate. Then what would happen? If it is successful, the structure will not carry main current, it will carry induced current, like agreed. And because you're providing a so-called low impedance path, the voltage rises are controllable, hopefully. Then because current is dissipated, people inside will not see serious potential. They'll see some potential, not serious. These are the overall concept. Franklin thought otherwise, but we shall comment on Franklin later onwards. But to understand this, to quantify this, what do we need? What do we need is actually expertise in multiple areas. I agree that compared to modeling of this cloud dynamics, this may be a silly thing for you. For us, it is a great thing because too many complex physical phenomena which are not quantifiable are involved. First is to have the air terminal receiving the lightning, which is called attachment process. We need to worry about. One is electric field intensification, which is responsible for the local discharge of air called corona, streamer, and leader. I will take next slide, subsequent slide to define this terminology. In other words, this is a microscopic phenomena. This is in the sense, remember, your gap and structure is in meters, hundreds of meters. This is in micrometers. This is in millimeter scale, and this goes in meter scale. We need to quantify all this in extensive simulation and calculation, because in this stage, number of free electrons rises to from 1 to 10 power 8. So it means your calculation in this big scale to small scale is very accurate. Then photo emission, photo ionization, many other things we need to take. And as many people make fun of engineers, they always go to a simplified model. Yes, we go to a simplified model, but still takes a lot of effort there. Then comes streamer and leader. If one can quantify and understand this, then only they can talk about lighting attachment. Because there's a lot of misunderstanding or misinformation. We have early stimulation emission terminal, charge dissipation array in the market. And unfortunately, they are sold in spite of the fact that standards are not supporting them. Then once there is a bridging mechanism, current wave, charge wave will go from ground to cloud. Even though shown here in the standards, don't worry, that's the way we analyze. Intense charge wave will go. In other words, your so-called conductor system is not a simple conductor. It will be actually behaving, if you have small, let's say, one floor building, your conductor may behave like an inductor for this current. And for a structure of this kind, it actually behaves like a wave supporting waveguide. Not easy to analyze. People have this concept, they go by. I'll talk about copper, gold, everything in the subsequent slide. So this is another issue. So here we talk about field, breakdown phenomena, and here now we'll talk about wave propagation modes in the various domain, TM, so on. Then here ground dissipation, another strange problem. Dissipative wave propagation here. So we have soil ionization, frequency dependent soil parameters, so on and so forth, getting more and more complicated here. So in principle, some simple thumb rules are given to you, but quantification, lot more efforts are required, not that easy. However, you can do some kind of the bound analysis. You can say things are within this order, so no need to worry. Okay, now going slightly deeper into these individual phases, and that will be necessary because we can comment on the so-called lever devices. So during the descent of main leader, as you shown in the first video, the charge is lowered. Part of the charge, very small fraction of charge is lowered. So field on the ground because of the induced charges become higher and higher. If you have a tall tree or structure, because of slenderness, the field intensification, the tip becomes much higher. That can lead to so-called local breakdown of air, because field is high in only region around the tip, not toward the air. So that becomes local discharge of air called current. Currents are very small, maybe few microamperes, and I don't know how many of you have seen this. At least in the very dark pitch night, you can see discharge from the treetops. Whole treetop looks like a glowing crown, so that's called Los Alamos discharge. That is showing corona, no effect on the tree because currents are very small there, but they produce high frequency noise. Then, if the field is become sufficiently high, these individual small micro discharges will become lengthier. From micrometers, they can come up to centimeters and meters, called streamer discharge, a kind of self-sustaining discharge. I will comment on this on the next slide. Then, after this, we will call arc discharge, called leader discharge will come. Arc discharge is required because that is self-sustaining discharge. So these mechanisms are involved in the attachment, which people ignore because of need of simplicity. Just to give a picture of this, now even though it's not from lightning phenomena, this initial micro discharge called avalanche, electron avalanche micrometers, then streamer discharge, not one, multiple streamer discharges are there within the same event, which is self-sustained. And if you want to make measurement of the lightning strike in the field, first you need to go to laboratory, learn how to take these pictures because intensity wise, time scale wise, they are different. We have to monitor, understand this, then only you can go to laboratory, field. Then we have the so-called arc discharge called leader discharge, which also goes in a zigzag or tortuous path. All this will formulate attachment process. Now, somewhat this here, because that is required for our discussion. The so-called arc discharge, what is? When it comes, it will not be there permanently. It will disappear immediately. Then one more arc discharge will come. After that time, the field is sufficiently high. This can continuously grow. In other words, these discharges, just because they are there in the first event, they will not sustain. Why I am commenting on this? We'll come to know about the last line. So this process is very common, very frequently observed in long air gap discharge in the laboratory, and we are sufficiently clear about the events, why it happens, why it's momentary, because of the balance between the heat production and heat dissipation. Then, of course, every event produces some space charge, and this I'll skip. Now coming to the so-called early streamer emission terminal. There are many varieties, many shapes, including a spheroid with a needle in the top, a cone with a needle in the top, and in battery operated with high voltage generator at the top. They claim streamers will come much before ordinary pipe or rod what you put on top of the building, called Franklin rod. So streamer will come, not so what. Just because streamer has come, it will not become leader. Without leader, nothing will propagate, that thing will cause bridging. So in other words, just because a device in quotes called early streamer emission terminal is present, no guarantee that it will produce a special protective area. In fact, many installations in Malaysia, even in India, they have failed. When you go to the vendor, oh, there's a small mistake in my connection with the ground, something they will tighten and go, all hoodwinking. In Malaysia, finally, government has banned these devices because the scientific community fought against this with evidences. Forget about theory, practical evidences on buildings and so on. But here it's still going on. And in addition to that, high voltage people know one more secret. If you have a long air gap, apply impulse to that, then measure the breakdown strength. Let's start with 1 mm vertical wire, then you replace by 1 centimeter rod, then I'll go up to a rod or a spear up to 40 centimeter. There are a gap of, let's say, 10 meters. All of them will have same impulse breakdown voltage. 1 millimeter to 30 centimeter, the large gap of 10 to 15 meters will have same breakdown strength. Why it is so? Because in the 1 millimeter wire, field is very high, but it collapses very fast in space. So in other words, our leader cannot be formed easily. We want leader to be formed or a big streamer to be formed, so it will not happen. Another evidence to show that just because somebody said something, it works. No. This is a well-known fact in high voltage for more than 4 or 5 decades. So this is called critical radii concept, is one thing, and that I have mentioned here. Now, another question here. No, these vendors have shown the performance in the laboratory. They go to some laboratory, high voltage laboratory, do some experiment. There are two categories. One category is the laboratory experiment has nothing to do with the functioning of the device. They have no connection whatsoever. Because one thing is certain, I'm sorry, sir, Indians still have the inferiority complex. White skin is superior to color skin. So that concept is there. You interact with some people. No. That person came from Europe, told me. So what? Did not come from heavens. He come from only Europe. People talk in this fashion. So this experiment has nothing to do with the working of device. First point. Second point is laboratory gap is less than 20 meters. We cannot simulate lightning. Even though phase-wise individual events are similar, but you cannot reproduce lightning in laboratory. They are different. That's how people, that demarcation required. I repeat again, high voltage laboratory is required to understand the phenomena stepwise, every step of the phenomena, training yourself, training your equipment, tuning your equipment. But you cannot produce lighting here, no way. And so what we do in laboratory, current you can achieve. You can go up to 300 kiloamperes for testing the devices. But voltage there is not more than 100 kilovolts. Whereas actual lighting voltage is hundreds of million volts. There are differences. On the other hand, if you go to a voltage generator, you can go up to maybe 5, depending on money and space, you got up to 20 million volts. But current is less than 2 kiloamperes. You cannot produce lighting in the laboratory. Anyway, in other words, the devices testing certificate, what is given by them, has nothing to do with, most of the time, nothing to do with the working of the devices. Many times, even the testing laboratories ignorant, they write something, they do something, they write something. Unfortunate thing. Then comes another great idea. This is a great idea because I know the name, but I'm not supposed to write the names. This is family business. Initially Franklin also thought this way. They thought if you put a grounded conductor, it will dissipate charge. Those charges will go to cloud and neutralize the charge. Oh God, the mobility of the ions in air is so small, it can never reach the cloud. So this is the unfortunate thing. So that business started. The father started the business. Same idea. He put barbed wire, like what you use for fence. Make a crown-like structure, put it on top of a tower. It will neutralize cloud. Everybody shouted at him. Then device is same, but philosophy changed. Advanced philosophy. They don't know. It will produce a chronospatial around the top of the tower. It will protect. Hey man, if you have a tower, tall TV tower, if you put a big electrode, probability of strike slightly reduces. It will not eliminate. But if you're protecting a building, that you cannot put a crown onto the top of the building and visually think that it will avoid strike. No. Yeah, we can talk about this in a long way. So this family business, because sun took over, philosophy changed, device remained the same, and all kinds of things are put here, unfortunately. And they think they can avoid lightning. No. Right now, there's no mechanism where we can stop or avoid lightning, except you can launch a rocket, small rocket with a spool of copper or the steel wire, and that can cause strike to that particular place. That is possible. And a recent experiment with a high power laser beam, we can direct the lightning to that particular point. But personal opinion, before meddling with the nature, please understand the ramification. That's not meddling with the nature and cause further more problems than what it was before. So therefore, this is another philosophy in market, which scientific community had never endorsed it. So what they do is they put their members into the standard roles and try to push their product. It's happening everywhere in Europe, in America, as well as in our country. But unfortunate thing. So therefore, this is another philosophy which never works in that way. Then comes another great idea. This gentleman was my friend, and afterwards he said, "I'm not your friend." So they have a special cable. This special cable is having a surge impedance of only 3 ohms. So the current flows to this cable, 3 ohms into 30 kiloamperes, for example. Voltage is only 90 kilovolts. I'll put insulation around the cable. So it will protect your building because current is going through this cable. And man, this cable impedance is defined for what is called transverse electromagnetic mode of propagation. That is, you inject equal and opposite current in the core and sheath. That is the cable mode of operation. Every section total charge and current is 0. That time you measure what is called impedance for transverse electromagnetic mode. Where is the opposite current in the practical lightning? There's no current, only one flows one way. There's no closed circuit whatsoever. So this another concept was going on. And for that matter, I want to stress one more thing. The first is cable is no meaning whatsoever. Then people thought, many of these people, many of the elders, I'm also elder now, but people think that they are elder to me, doesn't matter. So they think that putting copper will save. Please kindly note, even for a short length, it is the inductance to start with. The inductance of the strip or the conductor matters. The inductance is same whether it's gold, copper, or iron, because inductance two parts. One is external inductance and the internal inductance. Internal inductance we never consider for such systems. It is useless, especially in high frequency. So external inductance is same for all of them. There's no means to minimize this inductance. Nobody can minimize this inductance. So therefore, its voltage will be very high. If you, for example, rate of rise of current will produce approximately 6 to 10 kV per meter in a copper rod of approximately 0.5 centimeters or something like that. Kind. With the experiment we can show in laboratory. Then you would put multiple paths. Another idea. Good. Multiple paths are there. But kindly note, each of these multiple parallel paths will have mutual inductance. So you cannot divide the voltage rise per conductor by number of parallel paths. Not possible. So there are issues here, and therefore be careful. No special cable is available in the world or nature which can reduce the voltage rise. Inductance of the conductor matters. We use gold, copper, or any other metal is fine, so long as the corrosion should not have affect the joints. Other than that, any metal is okay for us. Putting parallel paths is good. However, kindly note, there are mutual coupling, so it's not divided by number of parallel paths. And there are something else skip because time. This concept I will have something more. There's another funny thing what is found in the, it's okay, but they think that by putting an insulator, 11 kV insulator, and isolate the ground conductor from the building can avoid current flowing to the building. First of all, there's no calculation of voltage rise. If you really calculate voltage rise, it will be hundreds of kV and above. This 33 kV or 11 kV insulator if you use, it can go up to 90 kV impulse. And other small one that is the telephonic insulator cannot take more than 33 kV. But it's a mental kind of what you call satisfaction that I isolated the down conductor from the building. Another concept. I don't think you can isolate the building from using such small insulators. More than that, these insulators will have rain, moisture, pollution, so they will start conducting much before you think. So I wanted now some time for discussion, so I thought I'd cover it up very fast. Summary. I think this point I can complex. Lightning is a very complex problem. Cloud dynamics is very complex, I know, but lightning is a sister or maybe a child of that. Very complex physical phenomena, difficult to model. So in fact, there are some science people who model the return stroke in a very simplified manner and call this as engineering model. I don't know why engineering is coming there, but there are highly simplified models available. But because this phenomenon is complex. In fact, how return stroke current evolves, nobody has any model except our group. Because it's very complicated, you have to do so many approximations. And this is a random phenomena. Why randomness is coming here? Because of the photoionization and availability of space charge pockets. It takes a arbitrary path. Then over time, people have made measurements, except in this subcontinent, we are lacking in that. So we have better understanding of the phenomena. In fact, our present standards, whether elsewhere or India, we are actually taking data from Burgers measurement carried out on Mount San Valtor in Switzerland. The same characteristics are applicable here. Because then people realize that, no, there could be some dependency on the local geography and the other dynamics, so we need to make measurements. So we are far away. Hopefully with the National Lightning Detection Network, we'll have a better idea of what's happening here. So we have more reliable database for designing protection system. And the protection philosophy is still qualitative. There are quantification possible for the deterministic part, but still a lot of qualitative analysis is involved, as a result of which people are ready to cheat us. Now, somebody wants to do a work, so we need to separate out which part you want to take. If you have enough time and energy, you can take both parts, otherwise only one part. Attachment process modeling, or after attachment, what happens? I'm separating it out because the time required for these are different. One is, of course, field computation is essential because everything is field dependent. Then if you want to model attachment, you need to worry about Townsend phenomena, electron avalanche, photoionization, and vibration, diffusion, all kinds of things you can add. But you can have a simplification there. Or you want to model about the second part. After a strike happens, what happens? You need to worry about how the wave propagate on a supporting conductor. What's the impact of the surrounding media on this wave propagation? What's the impact of soil on the wave propagation because of finite resistivity and permittivity? Likewise, it goes on. We need the expertise in multiple branches. Doesn't mean that we can stop, but why this cautioning? Because people come and talk about unsound theories, innumerable numbers of theories. From where they get idea, I don't know. Some of the theories are so blatantly wrong that even high school students can identify. So the opportunity is coming because it requires multiple discipline to be understood and involved here. And basically, you want to protect. There's a standard procedure as per our international standard, as Indian standard. You need to have air terminals, either in the form of vertical dots in the corners, depending on structure, multiple vertical dots, or a mat-like structure on the floor, then multiple down conductors, and a suitable grounding. Remember, all grounding resistance, what they measure and show is for power frequency, not for this. In this frequency, we have more of inductors than resistance. There are other issues there. Then we have to have, this is for the outside. For inside, all the junction boxes should have such protective devices because these electromagnetic phenomena induce large amount of voltage in the loops. You need to have such protective device to protect your computers as sensitive appliances. Then also next coming to the connection between the building and outside world, which is very dangerous because when the building is stuck, whole of the soil down will go up in potential. If we have a connection from this to distribution transformer, which is at normal potential. So these two grounds will be different potential. So there also we need to put SPDs. Otherwise, you will go up and come down. And whereas the transformer, distribution transformer ground, which is few hundreds of meters away, will at normal potential. This can cause a large potential difference in damage to the transformer as well as your appliance. There also we need to have protective devices to minimize damage to our equipment. This short one, I will not go through these details. We have, I think, some work on the bridging phenomena, current evolution, so on and so forth. I will not talk about that. This is one of the recent work for ADA. How to switch it on, I don't know. Sorry, this one is not switching on. This is basically, this work was not funded by ADA, but some project with the ADA. We got interest in this subject. When aircraft is floating in air, it has found that by measurement, not by us, by people in last century, that most of the times it's the aircraft which initiates lightning under thundercloud. Not that aircraft happens to be there. The probability is very small. I repeat again, under the thundercloud, aircraft doing takeoff and landing can initiate lightning, but there is no theory for that, nor calculation procedure. So there are following procedures which is applicable to structure on the ground. So we developed a model where we have, for a negative cloud to ground lighting, positive leader discharge, streamer leader discharge here, and negative discharge starting after some time in the nose cone. There are some gaps there. Finally, when become about 5 to 10 meters, they become self-sufficient. They'll start propagating unless you remove the thundercloud. This model was based on macroscopic modeling of the positive streamer leader, negative streamer leader, extensive field computation because the workup potential will fluctuate continuously during the process. This is one. And many things calculations are done on this. Another practical problem what we tackled is the that was one more thing. We could test the aircraft, actual aircraft, but they removed engine and controls before giving to us. We could inject the whole current of 60-70 kiloamperes to Tejas at the LCA Mark 1 model. Very recent work. This is a old work, 20 years old work. This is relative protection system to our second launch pad. This is coming from mobile vehicle assembly building a few kilometers away. These are the protection towers. There are issues with cables or many other things here. Third launch pad in Sriharikota and one more launch pad in Tamil Nadu is upcoming. Some work has started here on this direction. Some references. Thank you. Now I want questions so that I don't know if I'm able to answer all the questions. I'll make an attempt because this is a vast field. I mostly put my 60% time on lightning, other 40% on field computation, theory of moving charges and other things. That made me make an attempt to answer your questions. Because this is a very brief introduction. I know many things I skipped because 1 hour is given to me. I understand, but if you have questions, especially young people, because I'm become old now, 57 plus now, so I cannot think originally. I want to see young people asking very difficult questions.
So thank you, Professor Uday Kumar. It's an excellent talk. So you mentioned that you need more than 20 meters to simulate.
No, we cannot simulate in laboratory. But thing is,
below 20 meters.
No, we cannot. Sorry, I make correction in my mind. 20 meters. Why I mentioned is, I was talking about critical radius concept. So in the 1 meter, 2 meters, the people have done experiment in last century. So whether you are using vertical rod-like structure or horizontal conductor-like structure, for a given gap, there is a radius up to which the breakdown strength is same. So, for example, in a vertical tower-like structure, 1 mm to 30 centimeters if you go. That is whether you put a cylindrical pipe with a hemispherical top or a simple cut-open pipe or any of that kind, the impulse breakdown strength will be identical. Okay. Whereas in the wire, corona comes much earlier. You apply impulse voltage is rising, corona will come much earlier, streamer will come much earlier, but it will not propagate because field is localized. It will not propagate further on. So breakdown strength remains the same. This comment is for ESC terminal. Even if you don't understand anything else, this graph is given to you. So it's obvious that breakdown strength cannot be changed by putting something which can produce streamer earlier. But it will also produce streamer earlier than the other bigger conductor. Breakdown strength is same. In the laboratory, all the changes are similar. You can understand the phenomena, also time lapse of the image, intensity of various discharges are similar. Similar, not same, but you cannot simulate. Because when you scale down, you have to increase the pressure at that level. You need a voltage generator of that level. Not possible. That is there is an opportunity for people to cheat because they show something here and something. Scaling down for any, as you know, in your field, scaling down means everything must be scaled as to reproduce the phenomena. You only scale the geometry, but not the pressure, which is the pressure of the media, which is responsible for this event. Then how can we trust that? But we can understand, we can make learning exercise, tuning exercise, all things we can do, but we cannot reproduce. And incidentally, I just read, Jupiter has a lightning which is at least 500 times stronger than Earth. The planets have lightning, not only Earth, which our atmosphere have lightning, they say. Jupiter has lightning, which is much stronger than. So you can see the illumination covering very vast area from the satellite images they show. Very nice photo. Yes.
Thank you, sir. It was a nice lecture. So we have been using conventional type of protection for normal buildings. And also at some places we are using EEC based protection system. So certified by German or French. So this one. And also for HACPL lab, we have a iCloud laboratory building in Mahabaleshwar. So there we are using grid connected lightning protection system, like as you said, so different type of lightning rods and connecting it a grid, and we are this one. So my question is, so French and Germans, they are using this EEC based, and they are pushing here in India. So
small correction, we don't know. Some companies in France and German, not French and German. Some companies, they're pushing everywhere. They're pushing. US also they're pushing. Some companies are pushing, but this is not certified by the scientific community. What has happened? This International Conference on Lighting Protection. One time, this resolution signed by all the people who are in that field. On Kailari or somewhere, suddenly a lawyer appeared. The court has said, he has come. The vendors have given money everywhere, and he has gone to court. They have an order. Please do not criticize product of our customer or something. Yeah? This is not court. This is a scientific community. ESC terminal, if at all, acts as good as conventional terminal. No extra protection is offered. That's the truth. That's verified practically and theoretically. But the thing is, some companies will come and sell. They'll put theories, some laboratory experiment. Many people have approached me, the local vendors with the partners, and try to explain. Also, human being after some time will say, stop this nonsense.
So now, which is the most efficient way of
conventional protection system is the best for that IEC standard, International Electrical Commission standard still continues there. Some more people are there to protect the interest of the community. That is borrowed by Indian standards. Indian standards is parallel standards. That's copy and paste. So ESC terminal, if at all was as good as conventional Franklin done, then why waste money?
Is there any way to safeguard a large area of protection? So is there any way to protect as per this one?
Simple, sir. Do you have a big umbrella for the stadium? Why only lightning? You have a big umbrella who can cover the whole stadium. Nature, you have been facing nature. Then why only point it towards lightning? Why not the rain afterwards will come to earthquake and all? Nature is stronger. We cannot. Can we put an umbrella to the whole village? These people are talking meaningless. There's a death due to floods and all, not only lightning. Lightning is one of the events. So let's understand nature has its own scale and respect that. So protect, you have to ensure that during the field exceeds certain level, people should not work in open field. That's a rule followed by everywhere. So they say, when there is a thunder, go, something is there. Famous statement. Let's follow. No, not possible. In fact, I did not show some of the scary photographs. Discharges can run on the ground where there is a water tank up to 50-60 meters. Then all the protection mechanism, what I told about grounding and all, may not be meaningful at all. I just isolated them. There are some things stranger than what is there in. In other words, any engineering design, goal is to have a probability of small amount of failure, because otherwise it becomes very uneconomical to design. So guaranteed that way. Like I'm coming in a cab, and there's no guarantee that cab is in order, driver is in very good health. We don't know. Like this, you take risk in day-to-day life. We take some risk here also.
Thank you, sir.
Yes, sir. Yes.
Thank you for very detailed lecture and taking all the aspects. No, there are quite often there are demands from oil storage areas for protection of there.
Yes.
So if you put some Franklin rod there, it will attract the lightning strike, point where it strikes. So instead of striking at some distant place, it will strike the lightning rod. So what is your comment to do this? Because even thermal heating may initiate some damage to the, and that area is quite, there are many storage these things.
Yes.
So what will be your advice?
Yes, sir. Our storage tanks with very heavy metallic elements with a floating top. Floating top with the air, the fuel air mixture is actually the air just below, between the oil and the floating tank. If you can ensure those parts, no issue. The heating is only at the attachment point, at the topmost point, which is not exposed to this fuel air mixture. For what we have to ensure is the floating top should have good connection to the surrounding tank. For that, there is a flexible braces are employed so that connection is ensured. Otherwise, it's so huge. Heating will not be so high. So floating top with the multiple connecting braid connected to the tank. That is done. And attachment point is on top, no issue. Some heating is there, that is not exposed. That is where it is done. But putting isolated towers like launch pad is not done there because there are so many huge tanks. They will not economical for them. They live with that. So connection is sufficient. This connection is sufficient. There are some experiments in laboratory not only for this, also for electrostatics of these big ships which carry the fuel. After emptying the fuel, they are very dangerous because the fuel mixture is so volatile there. Some experiment for both these two purposes. Connecting braid is sufficient. It will maintain because the heating is so nominal in the whole tank. No issues there. Only the attachment point top, which is not exposed, not an issue. The connection braid will ensure that there will be no arcing inside that is sufficient. There are some people who talk about so-called additional special braids and all. No, they are only notional. Ordinary braids are sufficient. Braid means flexible conductor. It's not called the flexible conductor. Braids are basically woven thin wires so that they are flexible. That is sufficient.
Grounding is very important.
Grounding for the tank is not that important for that point because the instrument ground is not next to the tank because tank is so huge. the potential rise is not that high. But the instrument, if the instrument ground is also put next to the tank, then we have to worry. Otherwise, not an issue. In the anyway, potential rise in any case is inevitable. But large area is potential is nominal. For instrumentation, that itself is dangerous. In that case, we need to worry. What we do is try to equalize potential. If not possible, put SPDs at the extreme point so that the potential rise difference between the different parts are clamped to a particular value, more tolerable value. This problem is there in the radar system, many places where it is on top of the mountain and there is a flat area. Again, this tall tower-like structure, some antenna. There is a disc antenna on the side within 60, 70 meters, and all of them go to control room. Obviously, they will have potential difference because nobody can control them. And this mountain is, moreover, rocky mountain is a small amount of soil on the surface. Best thing is, yes, we can try to minimize by putting in interconductor network, and more importantly, at the input to the sensitive electron devices, put proper SPDs so that potential difference is minimized. Because supply is also in the mountain itself, there's no issue whatsoever. But the supply coming from the overhead line, transformer and protection is required. There we need a bigger surge arrestor. This can be quantified. These things can be quantified, no issue. But SPDs are essential. Class A, B, C coordinated SPDs are employed both in railways and these places. At the panel level, A, then in the so-called back level, B, then in the final instrument level, C are employed, coordinated such that. In the railways also same problem is there, and the problem is may not be so what you call phenomenal, but they have the problem. Northeast, they say if I have to reset, even resetting the system, I have to go to the remote place, which is along the track. They have to face snakes, bears, sometimes cheetah, sorry, leopard, not cheetah, leopard. So for them also it is important. So these employ the same principle. Signal lines also come along the track for hundreds of meters. That's very dangerous because they'll pick up. So SPDs are employed. There are still failures because some other reason, but SPDs, coordinated SPDs are good. Potentialize you cannot stop. Like when disease is inevitable, leave it back with the proper precaution. So SPDs are employed.
One more question, query, just for the anxiety. No, through several centuries since Franklin discovery of this, do you think there is any better technique than Franklin rod for production?
No, sir. No, sir. You can, if you want to have if you have a very sensitive system, use the sounding, not rockets, small rockets, 1 meter length with the spool, so that strike, we have to spend a lot of money. Strike is only to that point, not elsewhere. Because in many of the radar systems, you cannot put a tower around it, put a shadow area. That's one. But other than that, I don't subscribe to the laser beam also because you're affecting the whole thing, column there. But that laser right now requires such a huge power supply that we cannot afford that. Franklin rod is the only thing is still good.
But
What they say, what is good?
important thing is maintenance of that for a long time.
That's that.
Generally, I have experienced that generally there's a connection to the ground. They are broken or rusted or so people don't take care of.
Once in 6 months, inspection is required. Before the monsoon, inspection is required. They don't do it. But this is one problem. Other problem is nobody wants to use copper. If they use copper, they cover it. The copper is not recovered anyway because it sublimates in air. Just a small incident. In Bangalore Metro, they came to me, some other work. Near Malaysia, there's a monthly mall. To the main bus station, there's a metro line. They put copper conduct in the soil. Next day morning, it's not there. So, not the exposed copper, buried copper. Then they put a sentry, watchman, and put one more copper. Watchman is also taken away along with the copper. This is the problem because poverty is driving people to steal. So, the copper is not required, but this maintenance is required. Once in 6 months before the monsoon, they have to check. Because they don't do it. They don't do it. What to do? They think that like buildings also maintenance, we don't have maintenance. Especially coastal belt, the saline pollution is very strong. Corrosion is very strong. They have to maintain it. Lightning will find a path, but thing is, it will have a discharge there. But we don't want such discharges. Maintenance, I know, sir. I agree. This is a common problem. Maintenance.
Thank you.
Thank you. Yes, sir.
Great talk, sir.
Thank you, sir.
Sir, I just want to know that as the material, whatever the material, it is the not the conductor. It's a induction.
Inductance.
Main thing is the I struck there.
Yes.
So I just want to say that it's copper is also not required. It's aluminum is also can do.
What the thing is, non-corrosive, one point,
Okay.
non-corrosive. Second point is, when you have aluminum, making contact with the aluminum contact because of oxide layer is
Yes.
difficult. But this voltage, it automatically makes connection. But when you want to make measurement for your maintenance, that time it will yield. Otherwise, this voltage level, any small loose connection, it will automatically take care of itself. So that's the reason. If you want to check maintenance check you want to do, then aluminum is not. So
Is it
good.
a flat or a round one?
Nice.
Is better?
Very good, nice one. The inductance of the structure becomes minimal when we make the things wider. So strip is better.
Strip is better,
But the
yeah.
thing is, for mechanical consideration, some people may still
Yes.
prefer rod. That is, I agree with that. But strip is better for inductance.
Even for our instruments also.
Yeah, high frequency. For frequency, no issue whatsoever. With higher frequency, signal of the wider things are better.
Actually, we have a multi-core round one, but it was accepted. Then we
is a
go on
problem.
for the flat one. I just want to concern about it.
People are, this is a problem. So they say copper sublimates in air. Anything shiny sublimates. Nothing. People take it. There's problem with that. That's the reason when I was asking your colleague, do you make insurance for your sensors? Because somebody tells them it is anything, they'll seal away. Because when the Balsoor, they told me that the sea goes back and they do this testing of these missiles. Before they reach to take the debris, villagers will be waiting there, take the debris and sell it. Oh, then I said, poverty is the mother of invention. Because in Africa, they said, if they have earth mover, you forget about transformer, oil and all. If you have earth mover, they simply put earth mover, take the transformer itself. Oh, so poverty is the mother of invention, not necessity.
Sir, actually, these conductors, as it is a cheaper one, we can go as a metallic thing. Then we can repeat the 4 or 5 places so that maintenance, at least one will work out of the
I no issues. So long as now one more question they put, ergonomics. It affects the scenic beauty of the system. But transmission is banned in many places because civilians reward it. It affects, I don't know how many of them are real poets who can write novels or poetry on the scenic beauty, but they are covered. This problem is, we are facing this problem.
It's a very good point. You brought it instead of conductor, it's a inductor.
Inductance actually, at the lower, smaller end.
It has to go back again.
No, this inductor, because magnetic field is created, inductors will appear. That goes to ground. But if you have longer length, then it's a wave propagation effect. We have to see that. People have, when people argue means after reasoning, they say copper is better. It is not DC, it is a impulse. Okay. Because that is forced down to them. They have been encouraging their learning. So they don't want to change their problem. They want to say it. And one more thing, these down conductor will have a lateral discharge. That is common. So the discharge can come inside the window also, but that you cannot avoid because hundreds of kilovolts means there will be lateral discharges. So they think that they can isolate, it's safer. No, sorry, this discharge, if you work in high voltage laboratory, you'll see all these kinds of things, manifestations. So we know, we have seen in the laboratory experiments, discharge is very common.
The Mary mites.
No, this is there. Even though I'm also orthodox man, but I don't think that by chanting 10 names of Arjuna, it will go away. No way.
Fantastic, sir. Thank you.
Thank you. I want young people are not asking any question because I can do some more research before I retire.
Meet you personally.
My email address is there. So, okay.